Well, hey there, everybody. It's your boy, Mr. Perry, and we finally made it to polymorphism on lesson 6. You've heard about it in the previous lesson videos, so let's get into what it actually means. All right, so we're going to start by looking at this example hierarchy and, um, think to ourselves, okay, what if I wanted to make a program that would, simulate polygons and allow me to explore the behavior of polygons and all that kind of stuff? So the first thing we would have to do is we would have to think what attributes and behaviors we might define. Which of them are common to all polygons, and then which of them would maybe be separate for our different shapes, right? So consider that hierarchy. Feel free to pause the video and think about what would be, what do all polygons have in common? What are some attributes that they all have? And then what kind of behaviors might we want to program for them? What are some common maybe calculations or things like that that are associated with the various polygons? So feel free to pause the video and do a little bit of brainstorming. We're going to go ahead and move on here and see what we think. So for attributes, all polygons, well, they have a name, and then they have a certain number of sides. They are maybe equilateral or maybe they are not. We have the side lengths. And then for behaviors, we might calculate area, we might calculate perimeter. So there you go. That kind of gives you an idea of what are maybe some attributes we would define and maybe some behaviors we would define for this. And because this hierarchy is set up for us already, then we know this is a really good candidate for inheritance so that we can use polymorphism. So what is polymorphism? So variable types of a superclass can hold objects of the superclass as well as its subclasses. Those objects can be used to call methods which will behave differently if they are overridden in the various subclasses. And this whole idea that you can have each of the subclass behave differently, even though you're calling the exact same method, that's one of the advantages of polymorphism. So let's go ahead and look at an example here and start to work through how this would work. So up here, I've got an array list of polygons. I'm calling it my shapes. And of course, I'm using the superclass type up here because I want to be able to take advantage of polymorphism. So we've done that. And then now I'm going to go ahead and instantiate three objects here. I'm going to do polygon triangle 1 equals new triangle. And then polygon triangle 2 equals new triangle. So I've got objects of the triangle class that are being stored as polygon variable types. Now down here, I've got square 1 equals new square. So I've got a square object type that is being stored as one of the subclass variable types square. So I can go ahead and add those into my array list of polygons. And now I can go ahead and loop through every polygon that's in my shapes. And I can call the calculate area method. And obviously, the way that the triangles are going to calculate area is going to be a different formula from how the square is going to calculate the area. So again, that kind of gives you an idea of polymorphism, how that's going to work. Now we have to talk a little bit about compile versus runtime type. So variable types are checked during the compile time. So when you compile your code, when you hit run and it starts to compile, it's checking what are the variable types that we have in this algorithm that we have going on here. Now object types are checked during runtime. So after the code compiles, and then the compiler says, okay, this all checks out, I'm going to go ahead and run the program. When the program actually executes is when the object types are run. So what that means is variable types over here, those determine which methods can be used by the objects. So any method that is in the polygon class, then that can be utilized by triangle 1 and triangle 2. Those two objects can call any method that's in the polygon class. The square class can call any methods that are in the square class, as well as any methods that are in the polygon class, because again, those methods would be inherited. So the variable types over here, those get checked during compile time. When you click run and it checks the code, those get checked during that time. Now the object types are over here. And remember, the object type determines how the methods behave. So when triangle 1, calls the calculate area, it's going to calculate the area as a triangle. It's not going to calculate the area as a polygon. It's going to go to the triangle subclass and look for where that method is overridden, and it's going to behave that way. And then the square obviously is going to behave like a square because it's a square object as well as a variable of the square type. All right, so compile time. Compile time, when you click run, the compiler checks if the variable type has the method that you're trying to use. So we are trying to use the calculate area method. And so when you click run during compile time, it's going to check, does polygon have a calculate area method, and then does square have a calculate area method. And if the subclass or its superclass don't have access to the method, then the code's not going to compile. So if there's no calculate area in the polygon class, that code's not going to compile. If there's no calculate area in the square subclass, and there's no calculate area in the superclass, then this will not compile. However, if there is a calculate area in the polygon class, then that means the code will compile because it knows, the compiler knows that the method exists here. And of course, square is a subclass of polygon, so it knows it exists here as well. Now, runtime. So after compiling, the code runs, and during runtime, Java checks the object type for the method definition. So again, when calculate area is called, Java checks the triangle class for how to calculate the area. And if it's not defined there, it's going to calculate area as a polygon. It's going to go ahead and look at the polygon class and see if it's there. But of course, when you program the triangle subclass, you're going to add a calculate area so that area is calculated appropriately, according to the formula for a triangle. And then the same thing down here for the square class. When it's running, Java is going to go to the square class subclass and look for the calculate area method. So that's what's going to allow it to run differently. Now, if the method is not defined in the object type, again, it's going to check the superclass for the method definition. So that's just important to know how those things will behave. So again, polymorphism is the idea that the same code will behave differently depending on the object type at runtime. So, again, if we have an array list of polygons called myShapes, and if you use a for loop, an enhanced for loops to loop through myShapes and call the calculate area, the triangles are going to behave one way, the squares are going to behave another way, and then of course if you had any of the other subclasses, those would all behave differently as well. Now, one thing to note is that polymorphism works for non-static or object methods only. Static methods will always behave like the variable type, not the object type, which makes sense because, again, when you're calling the method using objects, right? Again, this would not be allowable on a static method because static methods, you don't use object types. Calculate area is being called with an object of the polygon class, so polymorphism will work. But again, if it was a static method, you would have to call it with the class, and static methods always will behave like the variable type, not the object type. All right, so that's basically it. Lesson review here. At compile time, methods in or inherited by the variable type determine the correctness of a non-static method call. At runtime, the method in the actual object type is executed for a non-static method call. And again, this is called polymorphism. For static methods, only the declared type is used to determine what method to execute. All right, folks, well, that's it. Thanks for watching. As always, make sure you leave a question or a comment on the video. I will see you in class.